If you've paid attention to a mechanic's work, you must have noticed the tools they use: screwdrivers, hammers, pliers, spanners, and many more. Sometimes they use a long-arm spanner and then use the short one at other times while repairing your granddad's old car, depending on how much space they have while loosening or tightening a nut. Now, if you try it yourself, when you loosen or tighten nuts, you'll find it more difficult to do the work by using a short-arm spanner instead of a long one. Why? A torque or turning effect of force is a turning action on a body around the axis of rotation due to a force. It is equal to the product of force exerted with the perpendicular distance between the axis of rotation and the line of action of the force. This distance is called the moment arm of the force. The longer the moment arm, the bigger the torque or turning effect of force produced. Given the same force, the torque produced at a long-arm spanner is greater than the torque at a short-arm spanner. This greater torque becomes the reason why you find it easier to work with a long-arm spanner. Now, how about using a screwdriver to loosen or tighten hexagon head screws? The screwdriver doesn't have a moment arm, so it can't produce torque, right? Well, this isn't true. Torque is applied here as well. First, let's look at the force. As we turn the handle of a screwdriver, the force of our hand on it makes the screwdriver rotate on its axis of rotation. This produces the turning effect of the force or torque. Now move on to the moment arm. Can you identify where the moment arm is in this case? You know that the moment arm is the distance between the axis of rotation and the action line of the force. The axis of rotation here is exactly at the center of the screwdriver. Therefore, the moment arm is the half-diameter radius of the screwdriver. As you see, the moment arm of the screwdriver is much shorter than the spanner, so you need to apply greater force while using a screwdriver rather than a spanner to produce the same turning effect. In this case, working with a spanner is preferable. Okay, let's continue our mechanic work. To open the nuts, let's say we use a double-arm spanner instead of one-arm spanner. All you have to do is exert forces with the same magnitude at each end, but in the opposite direction. So, you will pull one end and push the other end, which forms a couple of forces that turn the spanner about its center. So a couple is formed by two unlike parallel forces with the same magnitude, but not along the same line. These two forces act together to make a twisting movement, either clockwise or anti-clockwise direction. Turning the screwdriver, as we previously discussed, actually produces a couple as well, since there are two opposite forces with the same magnitude. So what if these two forces are applied in the same directions? Well, this does not make a couple, but this condition satisfies the principle of moments. The principle states that a body is balanced if the sum of clockwise moments acting on the body is equal to the sum of anti-clockwise moments acting on it. Or we can say that the system net torque is zero. This zero net torque condition is one of the requirements for a system to be in equilibrium state. Now, here is a question for you. Will a long screwdriver, just like a long-arm spanner, be easier to use for work rather than a short screwdriver? Tell us your answer in the comments below.